Welcome to my channel. Today we continue questions and answers in linear algebra. This is our part 2 of the questions and answers session. Now, so we look at the first question. The first question says that if the transpose a half of A equals to the inverse of this matrix, then find A, and specifically just require beta what beta is. So that means you must first of all find the matrix A and then identify beta. Let's just do that. We'll begin the right hand side to get the inverse of 2, -3, 1, -1. So begin by finding the inverse of this. And in order to get the inverse, the first thing you need is the determinant. You need the determinant of this matrix. So the determinant of 2, -3, 1, -1. How we get the determinant? We multiply this diagonal, get -2, and then minus the product of this diagonal, which is -3. So this gives you +1 as the determinant. So what about the inverse? The inverse, therefore, you take 1 over the determinant times the adjoint of this matrix. So this is the matrix. The adjoint you reverse this diagonal, -1, 2. So I reverse the elements in this diagonal. Then change the signs of the elements in this diagonal. So the elements in this diagonal are 1, -3. When I change the signs, this becomes -1 and this one becomes +3. So this is the inverse of this matrix. So what the question is therefore saying is that a half of A, the transpose of this, is the same as -1, 3, -1, 2. That's what the question is saying. Because the question says saying that the transpose of this, a half of A, is the inverse of this matrix. So we just found the inverse of this matrix first of all before we proceed. Now, so how do we find the A now from? To find A, this is a half of A transpose. So when we find transpose on both sides, what do we find? Transpose on both sides, what do we get? So just determine transpose on both sides. So I'll have a half of A transpose, then the transpose of that will be the same as -1, 3, -1, 2 transpose. But what is the transpose of this matrix on the right? The transpose of this matrix is just -1, 3, -1, 2. So that is the transpose. Now, so what that means, therefore, is that this part, the part on the left side, this part equals this part. Now, so what is this on the left? What I know we learned in our earlier video is that if I have A transpose, then find the transpose of that, what I get would just be A. So what that therefore means, let me just get some space. Let's get some space again. What that means, therefore, is that the transpose of a half of A transpose, this was transpose. What it means is that the transpose of this half of A transpose is just a half of A. So that means, therefore, this statement therefore means that a half of A equals to -1, -1, 3, 2. So what is A? Now to get A, multiply both sides by 2. Multiply this side by 2, this side by 2. So that this side by 2 and this side by 2. So this comes first. Now, when you multiply by 2 on the right hand side, what do you get? You get negative 2, negative 2, 6, 4. But what the question wants is just the picture, because I can see that A is negative 2. Like, because this matrix is equal to this. This matrix here is the same matrix. So that means A is negative 2, B is negative 2. Then it's a 6 there. But with the question wanted picture, so picture will be 4. So this is how we answer this. Let's look at the next question. Now, this is our second question. And we are given matrix A, then matrix B, and then we are told that if the determinant of A is 5, find the determinant of B. That's what the question is talking about. So that means that you have to manipulate matrix B until you find some constant times matrix. But what I'm saying is manipulate matrix B until it's in the form of A. And then from there you can now determine what the determinant of B becomes. So let's just look at what I'm saying we do. Now, so B that we're given is, let me just begin by finding the determinant straight away. So the determinant of B will be 5 of A plus 2G, 5 of B plus 2H, 5 of P plus 2I. And then this other one is 3G, 3H, 3I. And this one is P plus 3G, E plus 3H, and F plus 3I. Now the determinant of that. Now, so we need to manipulate this matrix until we get something like matrix A. And what if I check matrix A, I can see that we have A, B, C in the first row, D, E, F in the second row, G, H, I in the third row. But here I can see G and D. D, I can see D, E, F in the fourth row. That means the first thing I can do is to interchange row 2 and row 3. Oh, what did I say? I said D, I can see D, E, F in the third row, not fourth, the third row. Now, so that therefore means I have to interchange row 3 and row 2. Row 3 and row 2 interchange. What we know is that if you interchange the rows, the new determinant becomes the old determinant times -1. So the negative, the sign of the determinant changes. So let me put that negative there because we are interchanging the rows. So 5A, row 1 remains where it is. 5B, 5C, and then we've just interchanged these rows. This is D plus 3D, this is 3H, and this is 3I. And the other one, no, this is what is this? E plus, it was E plus, let me just add that. And this one plus F, just add that. And then we have 3G here, 3H here, and 3I. We just, sorry. This is supposed to be there. So let's just let me clear this a bit. Yes. So let me draw that here. Now, so I've just interchanged the row 2 and row 3, and you can see the effect of that is that I have minus outside. That the determinant changes, the sign of the determinant changes. Now, after that, you notice that if I was to subtract row 3 from row 2, I would have D, E, F in row 2 as it is in matrix A. So what I'm saying therefore, that the next step is to get the current, the new row 2, subtract row 3 from row 2. Subtract row 3 from row 2. So when that happens, of course, row 1 remains the way it is. Row 1 remains the way it is. And this was 5C plus 2I. So I'm just subtracting row 3 from row 2, and that gives me D here, E here, and F here. And this one remains as 3G, 3H, and 3R. So what will be the next step? The next step will be now factor 3 out of row 3. Out of row 3. So what you realize is that row 3 has been multiplied by 3. Let's say I have 3G, 3H, 3I. So let me factor out. Let me just create some space. Create some space here. And so what we know is that if you have a matrix and you multiply that matrix by some constant, the determinant of the new matrix will be multiplied by that constant. The original determinant takes that constant. Now, so let's just factor out. Oh, remember there was a negative here. There was a negative here, negative 1. So if you multiply, you shall have negative still outside. Now 3. We factor 3 out. This one remains as 5A plus 2G, 5B plus 2H, and 5C plus 2R. And this will be D, E, F, and this other one will be G, H, I. So at least we have row 2 and row 3 in the form of, because we're expressing matrix B in terms of matrix A. Now, subtracting a row from another row or multiple of a row from another row has no impact on the determinant. So the new determinant will be the same as the old determinant. Now, so what I want this time, if I was to subtract 2 of row 3 from row 1, I would move very close to what I want. So let me say that subtract. So to get the new row 1, I'm taking the original row 1 minus 2 row 3. So when that happens, it's minus 3 outside. So this one times 2 will be 2G, separate from 5A plus 2G, and then 5A. The same thing happens to this, and we have 5B, and this one be 5C. And then we shall have D, E, F, and G, H, I. Just as I've said before, is that when we subtract a constant, when you subtract a multiple of a row from another row, the determinant, the new determinant will just be the same as the older determinant. So it has no impact on the determinant. Now, so I can factor the 5 from factor 5 out of row 1, out of row 1. So when that happens, I would have negative 15. So 5 goes out, so that 5 times this negative 15 gives me negative 15, and what I will have here will be A, B, C, D, E, F, G, H, I. And what you see is that what we have here is A. But we've been told what the determinant of A is. The determinant of A, we've been told that is 5. And so that means that the determinant of B, therefore, is negative 7. And that is how you are to do. When you follow any sequence, you don't need to follow my sequence. The thing is, you just need to ensure that B is expressed in terms of A. The way I've done this, so you can think of a way of achieving it. Can think of a way of achieving that so that you manipulate this B to obtain a time constant, and you can think that might be the determinant of B is the same as negative 15 times the determinant of A. But the determinant of A was 5. And so that gives us negative 75 as the determinant of B. Now let's look at another question. Now there's this question. It says a businesswoman borrowed a loan of 1,500,000 Kenyan shillings to expand her business. Part of the money was borrowed at a rate of 7%, part was borrowed at 8% rate, and part was borrowed at 10%. So the amount borrowed at 10% was 4 times that borrowed at 7%. So the question is therefore that if the annual interest on all the 3 loans was 130,500 Kenyan shillings, find the amount borrowed at each rate. And the question is saying that use matrices. So use matrix to do it. So when you find this question, the most important thing is to extract the information that you get. So I've seen that this man was borrowed in 3 bits. There was one that was borrowed at 7%, another part at 8%, another part. We just say that the money borrowed at 7% interest BX, and that borrowed at 8% B. You can say that that would be 1, and the money borrowed at 10% is 8. So therefore, this tells me something. That the total amount borrowed was X plus Y plus Z, and this is what is said to be 1,500,000 Kenyan shillings. Now we are told of something here. That the annual interest on all the 3 loans was 6. Now what is the interest on X? The amount X was borrowed at 7%. So the interest will be the interest of 0.07. And that one borrowed, the money borrowed at 8% was Y, and therefore the interest will be 0.08. That is just Y times 8 divided by 100. And the amount borrowed at 10% was Z. So the interest that this money will accrue will gain Z out of 100, and that is just 0.0 or 0.1. That's 0.1. So those are the interests. So what the question is saying is that the total of this interest is 130,500 Kenyan shillings. So let's just write that. So the thing is telling us that 0.07x plus 0.08y plus 0.1z totals to 1,500. Now, there's something else that this question states. The question states that the amount borrowed at 10% was 4 times that borrowed at 7%. So that means that if I took the money borrowed at 7%, which is x, and multiply by 4, I would get the amount borrowed at 10%. This is what the question is saying. That the amount borrowed at 10% was 4 times that borrowed at 7%. So 4 times x gives you z. Or in fact, somebody can just say that this is 4x minus z is 0. I want to write. This is what I want to write. 4x minus z. So this is the other equation. 4x minus z is 0. So we now have this system of linear equations to solve. We can do this by reducing this system to echelon form. Reduce to echelon form. So that is what I want to do. I want to reduce the system to echelon form. So let me create some space here. Just some little space here. Now, so the first equation remains as x plus y plus z is 1,500,000. I want to multiply the first equation by 0.07 and subtract from the second equation so that I have 0 at this point. So x times 0.07 subtract from 0.07x equals 0. And then y times 0.07, you get 0.071. Subtract that from 0.08, and what you get is 0.011. Now this one times 0.07, subtract from 0.0, no, subtract from 0.1, you get 0.03. Now 1,500,000 multiplied by 0.07 and subtract the result from this. This one you can do your calculator and get 25,500. Just multiply this one by 0.07 and subtract that answer from this. Get 25,500. Now, I now want a 0 in this position. In the third column, not third row, first column position. Third row, first column position. To get a 0 here, I apply row 1 by 4 and subtract from row 3. So this by 4, subtract from this, I have a 0. Y by 4, subtract from 0y, I have negative 4y. And then z by 4, subtract from negative z, I have negative 5z. Negative 5z. And then 1,500,000 multiplied by 4 gets 6 million. Subtract from 0, you get negative 6 million. Now, so let me create some space here so that we finish our working. So what I now want is to use this to create a 0 here. In fact, you may begin by making this one 1 And the way to make it 1 is to multiply it by 400. If you multiply by 100, if you multiply this by 100, you get a 1 here. Multiply this by 100, multiply this by 100. But that's not what I want to do. What I want to do is to get a 4 here. The way to get a 4 here is to multiply this equation 2 by 400. Multiply equation 2 by 400 and subtract from equation 3 to get a 0 in this position. So equation 1 remains where it is. Equation 2 remains where it is. Now multiply this equation 2 by 400 and subtract from equation 3. So the first bit here times 400, you get 4y. It's not even subtracting, add. The result of this add, we shall multiply the 2 by 400 and then add the 2 over 3. So this by 400, you get 4y. Add it to this here of 0. 0.3 z times 400 equal 12 z. 12 z plus negative 5 z, that gives you 7 z. Multiply this one by 400 and you do that in your calculator, and then you get 4,200,000. You multiply this one by 400 and then subtract it. I don't get formula. What do you get? Let me just do it with my calculator. Just do it with my calculator. So that is 25,500. 25,500 times 400 times 400. So what I get there is 10,200,000. 10,200,000. Now add it to this, add it to this, add it to 6 million, and you get what I was saying as 4,200,000. Now, so what does the last equation tell us? The last equation tells us that z is divide both sides by 7, and we get 600,000 Kenya shillings. Now move to this other equation. So you're solving going up. Move to this other equation where there is z, put 600,000 and make y the subject. So you find that y will then be 750,000. 750,000. Now move to the first equation, substitute y here, 750,000, and z substitute 600,000, and then make x the subject, and x will be 150,000. And that's what the question wanted. The question wanted amount invested at 7%. We said the amount invested at 7% be x. That means it's 150,000. And the y, which was invested at 80%, is 750,000. And z, which was invested at 10%, is 600,000. That's how you do this question. Let's look at the next question. Now, let's look at this other question. It says, find all the values of x so that the following matrix A is singular. And we all know that a singular matrix is that whose determinant is 0. So that what the question is telling us is that find the determinant of this matrix, equate to 0, then solve for x. That's what this question is telling us. So let's just do that. Now we can find the determinant of the matrix along any or along any column when you use expansion. So since this column has 0, it's determinant along this column. Otherwise, you can do it along any column or along any row. But I've chosen this because it has a 0. So the determinant of A, I'm doing it along column 1, is x multiplied by the determinant of the matrix that remains when you delete row 1 and column 1. The row of x and the column of x, when you delete, you are left with 3, 1, negative 1, 1. Now this was positive, so this is negative 2. Delete the row of 2, the column of 2, we are left with x squared 1, and this is the negative 1, 1. So this must be 0 because we want this matrix to be singular. So when you do that, you have x. This is 3 minus 1 will be 4. So for x minus 2 into, this is x squared plus 1 is equals to 0. So we can cross equal sign this to this one, take the other side, and then 0 take the other side. So this becomes 2x squared minus 4x 2 is equals to 0, or x squared minus 2x plus 1 goes to 0. This is a quadratic equation which we can also solve by either factorization or use of quadratic formula. When you do that, you find that x is 1. So that means if x is 1, then this matrix will have a determinant of 0 or be singular. So that is what the question wants us to do. And that is exactly what we've done. Let's look at the next question. The question is, find lambda if the determinant of this matrix is 0. So it's just the same question we've done. It's just like the one we've done before. Find the determinant here at equal to 0. So in fact, these columns are command to find the determinant. So let's just do the question. I want to do it along the first row. So the determinant of 1, along the first row will be 1, multiplied by the determinant of the matrix that is left. When I delete the row of 1, the column. Delete the row of 1 and the column of 1, you're left with 4, 8, 5, 10. Then minus 3 is 3. Delete the column of 3 and the row of 3. The matrix that remains is 2, 8, 3, 10. Then plus, and you know how to get determinant of matrix. We already explained that, how the signs alternate, plus, minus, and so on. So now delete the row of lambda plus 2, and now the column of lambda plus 2, and the row of lambda plus 2. The matrix that remains is 2, 4, 35. Equate this to 0. Now, the first one here is 40 minus 40, which is 0. 40 minus 40 is 0. And this is 30. No, 20. 20 minus 24. 20 minus 24. That is negative 4. Then plus lambda plus 2 into, this is 10 minus 12. 10 minus 12, it is negative 2. Now what do we have here? We have 12, and here minus lambda minus 4. Now this minus 2 lambda. Minus 2 lambda minus 4 is equal to 0. That means that 2 lambda is equal to 8, or lambda is 4. Lambda is 4. So lambda should be 4 for this matrix to have a determinant of 0. For this matrix to have a determinant of 0, lambda is 4. That's how we do that question. Let's proceed with the next. Now, the next question says that find K so that this system of linear equations is consistent. Find K so that it's inconsistent. Consistent equation. I'll just begin by reversing row 3 or 2 and row 3. This equation 3. Equation 3. So that is what I mean is supposing we had augmented matrix for this system. This is the augmented matrix would be 1, 2, negative 3, 1, and this would be 0, 0, K plus 3. Yes, yes, and so that this is 3, and this will be 2K plus 1, and here it will be 0, here it will be 1. So this is what the augmented matrix would look like. So what I'm just saying now is that what we then do for this, I want just to interchange row 2 and row 3. Interchange row 2 and row 3. Just even before making it 1 0, just interchange, and let's see how the matrix looks like. It will be 1, 2, negative 3, 1, 2, this was 2K. This was 2K. 2K plus 1, and this will be 0. This will be 1, and this will be 0, 0. What was it here? It was 0. This will be 0, 0. K plus 3, 3. So this is how the method matrix would look like in echelon form, just before making it such a bit. Making this one to be 0. Because if I make this one 0, then there will be a value. There will be a value here and another one. Now what I'm interested with is this last bit. K plus 3 is equal to K. Now, for this system to be inconsistent, that means for this system to lack solutions, what we need to have is we need to have the left side being 0. We need to have something like this, 0 is equal to 3. That the left side should be 0 and the right side should be 3 double T's. So the question is, therefore ask you, how do I get a 3 if I have K plus 10? How do I get a 0 if I have K plus 10? So to get to 0, just equate K plus 3 to 0 and define that K will be negative 3. So that means if K is negative 3, then I will have 0 is equal to 3, which is 0. And that means that the system will then be inconsistent. And so that is how I do it. That's how I do it. So what I mean is that after this, after that, what I did was I knew what an inconsistent system is supposed to look like, how this matrix is supposed to look like the matrix in echelon form is supposed to have a 0 equals to a non-zero. So that means K plus 3 must be here. And so which means that K will be negative. That's how we do that question. Now let's look at the next question. So let's see what it says. Show that in the space R3, the vectors x, y, and z are linearly dependent by finding the scalars A and B, such that this linear combination is true. Now, we've already been given the other concept here. You know, the definition of linear dependence as always defined for vectors x, y, and z to be linearly dependent. What that means is that you can obtain scalars x such that a times x plus b times y plus c times z is equal. But in this question, we are given c as -3. So therefore, let's say we can obtain scalars ab and -3. And this is the simplest way to do it. We can obtain scalars ab and -3 so that abx, no, ax plus by minus 3z is. So let's just look at our question. Let's do the answer. So we get a and b and -3 be the scalars or constants. So a times x is 1, 1, 0. Plus b times y is 0, 1, 2. Minus 3 times z, where z is 3, 1, -4. I can check my video part 1 on the questions and answers in Linear Algebra on how I answered a similar question. By first of all, considering that we have the scalars ABC, and then we work out the same way we might work out for the dependence. And then where we find that the system had infinitely many solutions, let your constant C be equal to negative. So you can look for then A plus B plus B minus 3 is also 0. Then you have 0A plus 2B. This is 2B. Then plus 12 to be 0. So in fact, this equation and this one, this equation gives me A as 9. This other equation gives me B as -6. Because this 2B plus 12 is 0. That means B will be -6. I already have the values of A and B as required by the question. Let's look at the next question. Now let's do this question. We are given matrix A and we are given its determinant is 8. And the question is saying that if this matrix has a determinant of 8, what would be K? What would be K? So we've done a similar question. But the one of singular matrix, it was a question of this kind. And then the one that we find in lambda, if the determinant was equal to 0. So it was similar question. So that means this question, first of all, find the determinant of this question and equate to 8. And then solve for K. Now we can find the determinant along any row or along any column. I choose to find mine along column 1. So if I do that, I would have 2 into delete the row of 2 and the column of 2. You are left with 2K to 4 and 3K plus 7. Then minus K, delete the row of K and the column of K, and you have -1, 3. The row and column, you have -1, 3, and then 3 k plus 7, then plus k minus 2. Delete the row of k minus 2 and the column of k minus 2. You're left with negative 1, 3, and then 2. This is determinant. The question says is 8. So let's just simplify. This is 2k plus 14. 2k plus 14 minus 12. What about this? This is negative k, negative 7, negative 9, negative k, negative 7, negative 9. And this one is k minus 2, and the determinant here is negative 4, negative 6, which is negative 10. And this gives us 8. So let's just simplify this first bracket. I have 2k, so I write it here. I have 2k here, 2k plus 2, 2k plus 2 times this 2, that means 4k plus 4. 2k plus 2, multiplied by this 2 is 4k plus 4. What about here? Here I have negative k into negative k, negative 16. What about here? I have negative 10k plus 20 minus 8 is equal to 0. So I've taken this 8 the other side of it. Let's open this bracket. This 4k and this is negative 6k. I have 4 constants here. I have this other constant. What about here? K squared plus 16k is equal to 4. Let's see what that gives us. Simplifying this, I have k squared, I began k squared, then that will be plus 10k, plus 10k plus 16 is equal to 3. This is a quadratic question which we can all solve. And when we do that, solving this, solving will yield k to be negative 2 or negative 8. So this becomes solved by either quadratic formula or by factorization. Factorization is easy because this equation can be factorized. Let's look at the next question. Now, this is a very simple question here. You're given matrix A, given matrix B, and then you have to find K. If matrix A plus the inverse of A plus B would give you Ka. So the only thing to determine here is just A inverse. The rest are very simple. Just add the matrices and then add, which is very simple. So we display the A inverse. Using Jordan. And I also taught you how to find it by use of adjective. So you have 2 ways. But now let me use the first one. Let me use the first one. Because Jordan. What that says is that if I have this matrix, then this is 1, 1, 4. And this is 4, 5, 7. Then I can write here the identity matrix of a 3 by 3 matrix. Identity matrix for 3 by 3. And I do some elemental row operations on this. When this matrix on the left finally becomes identity, when this matrix here on the left here finally becomes identity matrix, whatever here will be the inverse of this matrix. That is what Jordan method, how it works. Now, so the first thing I want to do is I want to create a 1 in this position, so that row 1 should now be the original row 1 times a third. And when that happens, I have 1, 4 out of 3, I have 2 out of 3, I have a third, 0, 0. Then this other one I will not touch anything. 4, 5, 7, 0, 0. Now, so what I want now to use this one to create a 0 in this position and a 0 in this position. So what that means is that for me to get row 2, I want the original row 2 minus row 1. And for me to get row 3, I want the original row 3 minus 4 row 1. Let me just write what I get and I do that. Row 1 remains where it is. Row 1 remains where it is. Now, row 1 times, row 1 from row 2. This gives me 0. Then this minus 4 out of 3 is negative a third. And then this 4 minus 2 out of 3. But that is the same as 10 out of 3. And same as 10 out of 3. And then this minus a third is negative a third. And then this will be 1, 0. Now you can see, I think you can see, and if you cannot see, at least you know what I'm supposed to be doing. I've stated it. Now, I want to get new row in form of row 1 from row 3. So 1 times 4 from 4. This times 4 is 16 out of 3. This one times 4 is 16 out of 3. It is out of 3 that I'm subtracting from 5. And I get my third. Now, 2 out of 3 is 4, 8 out of 3. It's this 8 out of 3 I'm subtracting from 7. And this is 13 out of 3. 13 out of 3 my species. I you can see that. You can write it properly. Now, this times 4 would be 4 out of 3. Separate from 0, they are negative 4 out of 3. Then this is 0 and this is 1. Next, I want a 1 here. So what that means that my current to get row 2, I need the current row 2 times negative 3. So when that happens, first of all, row 1 is it is, and row 1 is 1, 4 out of 3, 2 out of 3, a third, 0, 0. And this is the one I multiplied by negative 3 to get 0. 1, negative 10. 1, negative 3, 0. So I just multiply by negative 3 over there. And this one remains where it is, we don't touch it. Negative a third, 13 out of 3, negative 4 out of 3, 0, 1. Now, having created this one, I want to use it to get a 0 in row 1. So that means that the new row 1 can be achieved by the original row 1 minus 4 out of 3, 4 out that's minus 4 out of 3 of row 2. And I also need the row 3 to get a 0 here. So this one is the only non-zero element in its column. That's the same as this one. This one is the only non-zero element in column 1. So I want this one to be the only non-zero element in column 2. So I get a 0 here. So I need the row 3 to obtain by the original row 3. This row 3 plus a third of row. Let's get some space here. But this one already used it. So should remove it. So these are steps for the games. 0 by 4 out of 3 from this, 1. 1 by 4 out of 3 from this is 0. This by 4 out of 3 will be negative 40 out of 3. This negative 4 out of 3 is subtracted from 2 out of 3. And you get 42 out of 3, 40 out of 3, which is 14. Now this times 2 out of 3, times 4 out of 3 is part of the subtract from that. So what you have is a third minus 4 out of 3, which is negative 1. And then this then 4 out of 3 would be 4. Yes, okay, multiplying by 4 out of 3 be negative 4. That negative 4 subtract from 0, you get 4. And 0. And this row is the one we're using, so we just write it. Now, so I want a 0 here. And I've already said that I'll get that by row 3 plus a third of row 2. So a third of 0 plus that gives me 0. A third of 1 plus that gives me 0. A third of negative 10 will give negative 10 out of 3. Add this to 13 out of 3. And this gives you 1. And then a third of this is a third. So that a third added to negative 4 out of 3. And that gives you negative 1. And then a third of this is negative 1 added to 0. get negative 1. Then it's equal 1. That's okay. So those are the steps we are still doing. Find the inverse by those done. Of course, you have the other method. This question was not specified. Did not specify the method for you to use in determining the inverse. So you just choose on the method you think is easy and fast. Now we have this one. We use it to create a 0 here and a 0 here. So how do we create a 0 in row 1? We need the current row 1 minus 14 of row 3. And here, what about in row 2? We need the current row 2 plus 10 of row 3. What does that give us? Let's begin the row 1. This by 14, subtract from bracket equals 1. This by 14, subtract from bracket equals 4. This by 14, subtract from this here. This by 14, get negative 14. Negative 14 subtracted from negative 14, subtracted this from negative. This gives you 13. This by 14, get negative 14. Negative 14 separate from 4, get 18. This by 14, get 14. Subtract from 0, we have negative 14. Now, we now multiplying by 10 and adding the results. So this by 10 added to that is 0. This by 10 added to that is 0. 1. This by 10 added to this is 0. This by 10 is negative 10. Added to 1, get negative 9. This by 10 is negative 10. Added to this, get negative 13. This by 10 is 10. Added to this, you have 10. And this other one remains by 0, 0, 1, negative 1, negative 1, 1. And so you remember what I said when we began. I said that we want to act on those two matrices so that the matrix on the left was to become identity matrix and the one that will go around to be the inverse. So you already have identity matrix here. And so the inverse of A is this. So the inverse of A is 13, 18, negative 14, negative 9, negative 13, 10, negative 1, negative 1, 1. That's the inverse of A. So that means we are now ready to answer the question. The question was A plus A inverse plus B should give us KA. So what is A? So now back to the question. A is 3, 4, 2, 1, 1, 4, 4, 5, 7. A inverse is 13, 18, negative 14, negative 9, negative 13, 10, negative 1, negative 1, 1. And it is negative 10, negative 14, 16, 10, 14, negative 16, negative 6, negative 6, 5, 6, 6. This is going to give us K times A. A is 3, 4, 2, 1, 1, 4, and 4, 5, 7. Let's work on the matrix. Matrix is on our left side and see what we get. So let's add this matrix on the left. We don't need to add all of them. Of course, we know that if you have matrix A is equal to B, we know that if matrix A equals to B, then the corresponding elements must be. So for instance, if I add the first element, A should be equal to 3k. So this 3 plus 13 is 16. 16 minus 10 is 6. And then 4 plus 18, that is 22. 22 minus 14 is 8. And then 2 plus negative 14 is negative 12. Negative 12 plus 16 is 4. So do that. Given for this, find the value there, find the value there, find the value there. Find the value here. Find the value here. Find the value here. Just adding this matrix on the left. And when you do that, should be equal to the right. The right one is 3k, 4k, 2k, k. Okay, I'm just multiplying k inside this matrix. 4k, 5k, 7k. What I know is that this element should be equal to this element. This element should be equal to this element, and so on. So just need one of them. That is why you need to do one of them. This would be 6 is equals to 3k, or k is equals to 2. When you don't use this, it will be 8. I think these matrices are equal. 8 will be equal to 4k. And again, this would mean that k is 2. So you just need one and to get the result that is equal. Let's look at the next question. Now, so this question says solve difference in linear equations. So this is what you know. You know that this is same as if I was to multiply this from this column, I would have x plus y plus, of course, this is z plus z is equals to 5. And this row and this column I would have 2x plus 4 plus 2 z is 8. This row and that column I would have x plus 2y plus 2z is 8. So this is the same as this. So in fact, if you are given this, you don't write this for you to begin solving. Just know that they are the same. And you must know that now we can solve either by Gaussian elimination, or Gauss-Jordan, or by Cramer's rule. The question here has not specified the method to use, so it's easy to choose any of the methods here. Now let's solve this, and let's extract augmented matrices. 4, 2, 1, 2, 2, 5, 8, 8. I already have 1 in this position, so I want to put 2 to have a 0 here. That means I have to take the current of 2 minus 2. I also want to put 3 to have a 0 here, so I have to take the current of 3 minus 1. So when that happens, rho 1 remains the way it is. And this by 2 from that I have 0. This by 2 from that I have a 2. This by 2 from that I have 0. This by 2 from that I have negative 2. Because this will be 8 minus 10. Then this minus that I have a 0. This minus that I have a 1. This minus that I have a 1. And this minus that I have a 3. Of course, from here, I already know that y is negative 1. Because this is 0, x plus 2 plus 0, z is negative 2. So that means y is negative 1. But I want to And if y is -1, I can come to the last equation. Y here plus z is equals to 3, but y is -1, so I can also get z and then come back here and find value of x. But I don't want to do that. Let me just create a 1 here. So, over 2 times this will be 1, 1, 1, 5, and this will be 0, 1, 0, -1, and this one remains the way it is, 0, 1, 3. Somebody else will also have interchanged row 2 and row 3 in this step. But I didn't want that, but you can still do it. Now, so I want to do row 3. What I just want to do is take the current row 3 and minus row 2. So that row 1 remains where it is, and row 2 remains where it is. And so now row 1, row 3 minus row 2. Row 3 minus row 2, this is 1. So this will be 0. And so this will be 1. And so this will be 1. From here, I can see that z is 4. I can see that z is 4. I can also see that y is -1. The way we had said. And so if z is 4 and y is -1, and what we have in equation 1 is x plus y plus z is equal to 5. X plus y plus z is equal to 5. But y is -1, z is -4. So those two give us 3. So that x becomes 2. And so that is how we do this question. That we report the next question. We have this question that we give matrix A and we are asked for the condition for A inverse to exist. What I know is that A inverse exists if the determinant of A is not equal to 0. If the determinant of A is not equal to 0, then A inverse exists. So what that means, therefore, let's just find the determinant of this matrix and say equate it to 0 and see what K would be. So for A inverse to exist, I'm getting the determinant. Let me do it along the first column. So 1 into, when I delete row 1 and column 1, K, and then 1, 1. Then minus 2. When I delete the row from the column of 2, I'm -1, 3, then 1. And I'm saying that for the inverse exists, this will not be equal to 0. So let's just find what this is. 1 minus 3. And this other one is -2. -1, -4. Now -1, -3, which is -4. Not be equal to 2. So what this means, therefore, let's just call it by terms. -k. This is +8 plus 1 not be equal to 0. So that means k, when I take k the other side and 9 remains the other side, k should not be equal to 9. And that's the answer that we are looking for. So the condition for A inverse to exist is that A should not be equal to 9. A should not be equal to 9. So that is the condition. And it answers the question at hand. So we look at the next question. The question is, consider the following system simultaneous equation. Find the constants A and B so that this system has infinitely many solutions. And we looked at a similar question before in one of our videos. Let's just see how to answer this question. So I want to reduce this system to echelon form. So the first equation remains the way it is. And I want to create a zero here. That means I subtract equation 1 from equation 2. So when I subtract equation 1 from equation 2, I have a 0 here. This from that I have a 1. This from this I have a negative z. And this from this I have a z. I also want a 0 in this position. That means I must take from 3, equation 3 minus 2 equation 1. Equation 3 minus 2 equation 1. So this times 2 from that equation 0. This times 2 from this. I have 1. You see, this is 2y. And this is, so I have m1 minus 2y. So this is equal to the same as 2 minus 2. And I just factor y out. That's what I'm writing. M minus 2 factor y out. Now, multiply this by 2 to get 4z. 4z from this CFZ. Multiply this by 2, subtract from this to get b minus x plus y plus 2z equals 2. Y minus z is 0. Now use this y to get a 0 here. That means you are multiplying equation 2 by m minus 2. And then subtract the result from equation 3. So this one, y, multiplied by this, you get m minus 2y. Subtract from m minus 2y over 0. Now come to this other part. You have negative z multiplied by m minus 2. And then subtract the result from z. So what we then have just z plus m minus 2 z. Or in fact, let me just simplify it. Just simplify that. What you have is just z plus m z minus 2z. Or lz minus z. Or m minus 1. That's it. So what I want to do, I just multiply this by m minus 2 and then subtracted the result from z. That coming up with m minus 1. We write it properly. M minus 1. And then multiply this by m minus 2 there and subtract the result from this and get a minus 4. So the question is, what is m and what is b if this system is to have infinite solutions? If it is to have infinite solutions, this part must be 0 and this part must be 0. So what that therefore means that n minus 1 must be 0, which implies that n is 1. And also b minus 4 must be 0, which implies that b is 1. That is how you answer this question. Thank you for having accompanied me from the beginning to this end, and subscribe to my channel to get more lessons.